Trigonometric integrals. So here we're going to figure out how to integrate powers of sine and cosine. So first, let's recall how to find the integrals of sine squared x and cosine squared x. We saw that in order to do this, we used the trig identity that said sine squared x is equal to 1 minus cosine of 2x over 2, and that the identity holds that cosine squared of x is equal to 1 plus cosine of 2x over 2. And once you rewrite with those identities, it's simple to go ahead and take the integral. Alright, how about if we had a power of 3? Let's evaluate the integral of cosine to the third power x. The way we're going to attack this is we're going to use another trig identity. We're going to use the Pythagorean identity that says sine squared x plus cosine squared x is equal to 1. Or just rewriting it, cosine squared of x is equal to 1 minus sine squared x. So we take our integral of cosine cubed x, rewrite it as the integral of cosine squared x times cosine x, make our substitution for cosine squared x of 1 minus sine squared x. And now we're going to do a substitution. We're going to let u be equal to sine x, and that means the derivative du is equal to cosine x dx. We go ahead and make the substitution. My integral becomes 1 minus u squared times du. We know how to integrate that to get that our integral is equal to u minus 1/3 u cubed plus c. And now substituting u back in, we get that the integral of cosine cubed x is equal to sine x minus 1/3 sine cubed x plus our constant c. So this trick here, where we peeled off even powers of cosine, is going to show up again. In our second example, let's look at a fourth power of a function. Let's do sine. In order to do this one, what we're going to do is we're going to use the identity that sine squared of x is equal to 1 minus cosine 2x over 2. And we can use cosine squared of x is equal to 1 plus cosine of 2x over 2. So the first thing we'll do is rewrite the sine to the fourth as sine squared of x all squared. Now we'll make our substitution in for sine squared x to get the integral of 1 minus cosine of 2x over 2 all squared. Then we'll expand that out, and we will factor out the 4 to make it a little bit easier to look into. So now I'm finding the integral of 1 minus 2 cosine 2x plus cosine squared of 2x. And we know how to find the integral of cosine squared 2x. We're going to rewrite cosine squared of 2x using that identity. So here, cosine squared of 2x becomes 1 plus cosine of 4x over 2. Now, just to make it easier to look at, I'm going to factor out a 1/2 from the integrand to get this. And now it's just a straight integration. We simplify what's inside our integrand. And when we bring it over, we go ahead and integrate. We simplify our answer to get that the integral of sine to the fourth x is equal to 3/8 x minus 1/4 sine of 2x plus 1/32 sine of 4x plus c.